In this video, I'm going to show you how to find the real solutions of an equation using a graphing calculator. So let's look at the statement that I have here. It says to solve the equation f of x equal to 0. This f of x could be any expression involving x. It could be a quadratic or what have you. The right side is 0. So in order to solve this, the statement is saying graph y equal f of x, and then the zeros of the graph of this function y equal f of x will represent the solution to the equation. So let's look at an example of what we're stating here. So let's look at the first equation. X squared minus x is equal to 6. We want to solve. So here we're finding the real solutions of an equation using a graphing calculator. So what we're going to do is we're going to get these answers by graphing. So what we have to do then is write this equation so that the right side is 0. X squared minus x then minus 6 will equal to 0. And the x squared minus x minus 6 will represent the function f of x in this statement. Okay. So what I'll do then is on my graphing calculator, turn it on, go to the y equal, and here I'm using the TI-83 plus. The 84 plus will also basically have the same type of features, and there's more advanced calculators that you can use that can do a lot more, but there's some instructors that may not let you use those calculators. So this is the one that was more popular at the university where I taught. So let's look at what I have here. Okay, so I have some of these functions entered already, so in order to save some time. So x squared minus x equals 0. There it is. So this is y then is equal to, and then this would be my f of x. Okay, so that's what I'm going to graph. So I'm going to go and just graph this. And I get a nice parabola. So basically what I'm going to do is we're going to find the zeros of this graph. The zeros simply represent the first components of the x-intercepts. So you can see in this, for this particular case, that it appears that the graph crosses the x-axis at 1, 2, 3, 0. So 3, 0 would be x-intercept, and over here on the left side this is 1, 2 in the negative direction, so negative 2, 0 would represent another x-intercept. So minus 2, 0 and 3, 0. Okay, so the numbers then that make the expression 0 are 3 and negative 2. So the solution to this equation from this particular graph is consists of the numbers 3 and negative 2. Now you can also check this out on the table. So go second and hit the table, and you can see then that when x is minus 2, the y is 0. So negative 2 is a 0. So according to the statement we just made a while ago, negative 2 then will be a solution. Down here you can see 3, when x is equal to 3, y is equal to 0. So 3 is a 0 of this graph, so 3 is also a solution. So the solution then for this system would be negative 2 and 0. Negative 2 and 0. Now this works out nicely in this particular case because the answers are integers. That's not always going to be the case. So let's look at the next equation. X squared minus 2x minus 2 is equal to 0. Now this one can be solved using the quadratic formula. The first one could have been solved by factoring. Could have been solved using the quadratic formula. So there's other methods you can use, but in this case I'm emphasizing the graphing calculator. So for this particular one then, I want to graph it. Okay, so this one already has the right side 0. So my f of x is x squared minus 2x minus 2. So I have it right here. So let me highlight that particular one. So take this one out. hit enter. So this one now, the equals is highlighted, so now I'm going to be graphing this one. So I hit graph, and there I have it. Now in this particular case, if you look at the table, you can see here that this one appears to, if you look at this appears to cross the x-axis at 1, 2, 3, 0, and over here close to -1. But if you look at the table, you see that at 3 it's 1. So we go to the negative side, we don't have any integer solutions to this one. Okay, so in this case what we're going to do, go back to the graph, is okay, I want to find this particular one. So it's not an integer, so what I'm going to do is I'm going to go second and go to the calculate menu, and we're finding the 0, so I'm going to hit number 2. Okay, so notice here on the left corner at the bottom here, it says left bound. So what I want to do is when I put my little cursor, hit the arrow key here to the left of this bound and hit enter. Now look at what it reads now here at the left corner, right bound. So now let's move the cursor past that point of intersection just a little bit and then hit enter. And then it asks for a guess. Here you can just ignore that and just hit the enter again. And notice here it tells me x is equal to minus 0.73205 and so on. Y equals 0. Okay, so the fact that it tells you y equal to 0 here tells you that this value right here is a 0, which means it's a solution to this equation. So one solution to this equation is negative to 3 places, negative 0.732 right here, negative 0.732. Now we need to find the positive 0 over here. Okay, so again I'm going to go second and hit this trace, which accessing the calculate menu, and I want 0 again, so I hit 2. So as for a left bound, so this time I move it over, hit the arrow key right to the left of this point and hit enter. Now it prompts me for a right bound, so go to the right of that value. It's past slightly, it could be there or it could be a little bit higher, I could put it up here, still going to work as long as it's past it. Hit enter, you can ignore the guess, and you see 0, x equal 2.732 to 3 places. And the fact that y is equal to 0 verifies that this value right here is a 0 or a solution to this equation. So the two solutions to this equation found using the graph and the 0 function are negative 0.732 and positive 2.732. Okay, let's go to the next one. Now this one's an exponential equation. One way to solve this would be using logarithms. Take the logarithm of both sides, either to base e or to base 10, and apply that procedure and solve it. But we're solving these by graphing, so I'm going to go to this menu again. And I want to cancel this one over here, so I hit enter on that equals, so it cancels that one. And then I want to graph this one, hit enter, and then I hit graph. And again, notice that this one I have to make the right side 0, so I'd have to rewrite this as 2 to the x minus 7. 2 to the x minus 7 is equal to 0. That's why here I have 2 to the x minus 7. Okay, hit graph. And you can see that this appears to cross the x-axis at just one point. So I expect one solution. So again, if I try to use the table, it's not going to be an integer solution. So just to save some time, I'm going to use the same method here. Go to second, calculate, hit 2, and then left bound, so go to the left, just slightly to the left of that, hit enter. and then past it, right bound, right there, hit enter. For the guess you can ignore, and here it is, x equal to 2.807, so on, y equals 0. So if I run this out to say 3 places, my solution to this equation here is 2.807 to 3 places, 2.807. That's my solution. Okay. The fourth one is again an exponential, a little bit more complicated. This little tricky here, but you could actually just use regular logarithms, but you'd have to factor this out. You'd have to factor this out, and you'll get 2 equations and solve it. But again, we're emphasizing the calculator here, so again, I'm going to come and deselect this one here, and then select the one I want to graph, which is this one here. So this one has one side 0, so my f of x function is just e to the 2x minus 2 e to the x minus 3. So you can hear it, you can see it right here entered in. Okay, so I hit enter here to select it, and then graph it. And again, you can see this, it appears to just cross at one point, so we expect a solution right here. And again, it's not going to be an integer value. If you check your table, you won't get any integer or whole number value for this. So again, I'm going to go second, and then trace, which is accessing the calculate menu, number 2. There's my little cursor there. For the left bound, just go to the left of that. Let me go a little bit further back right there, hit enter. Right bound, so go past this point. Here we go, hit enter. I'll just ignore the guess and hit enter. And here it is. So if I round this out to 3 places, notice y equals 0. So this assures me that this is a 0 for the graph. So 1.099 if I round off to 3 places is my solution to that equation. 1.099. Okay. The next one is a log one. I already have it entered here, so go to the y equal, and I want to deselect this one here. And then select this one. So again, this one, to write it so that the right side is 0, this would be log of x, and keep in mind that there's no base indicated, so this is base 10. So it's log of x to base 10 minus 0.3 equals to 0. Okay, so here I have it. So I hit enter to select that one, and then I graph it. Okay, so this one, again, appears to have one point of intersection here. So I go second, calculate, number 2. Okay, I'll put my cursor right there for the left bound, hit enter, right bound, get it over, make sure it's past that point, hit enter, ignore the guess, and I get 1 point. Notice that y equals 0, so this again confirms that this is a 0. So the solution to this equation is 1.995. 1.995 to 3 places. Now you say, well, what happens if the graph does not intersect the x-axis? Well, then you have no real solution. You have no real solution. So if you have a parabola, for example, the graph is a parabola and it's above the x-axis opening up, no points of intersection, that equation would have no solution. Or say a parabola that opens down, that's below the x-axis, does not cross, again, no real solution. Now, they'll have imaginary solutions, which you can get using other techniques, but this procedure will only give you the real solutions of the equation. If you want the imaginary solutions or the complex solutions, you'll have to use other methods, say the quadratic formula and so forth. But this technique works fine for any equation. This will also work for trigonometric equations, and I have some videos on that. On other exponential equations, you can check those out. And I also have another video on my DrTMath&More online. I'll put a link on this video, so if you want to check those out. I have some other calculator videos. I have some other videos on trigonometry, some calculus. So if you want to see those, please click on the link that I'll put up here, and please subscribe. And if you have any suggestions on other videos that you want to see, please let me know. And if you subscribe to my channel, I surely will consider your requests. Thanks again. We'll see you in the next video.